Madhukar to start recording so that we have recording. Madhukar. Okay, Madhukar has already done that. So the topic which we'll be covering today is evolution of mobile technology 1G to 6G. Let me take the pointer. Okay. So can you guess who this gentleman is? If you want to answer, you can open the mic and answer. Okay, let me proceed. He is Marconi. And as all of you must be knowing that he was a person who established a communication setup over a 3 kilometer in 1896, and he was using the Morse code concept. So, so some sort of wireless communication started long back in 1846 itself. And do you know him, this gentleman? Okay, so he is Cloud Shannon. Cloud Shannon, and for what he's famous, can anybody tell me or guess?
Answer.
Yeah. So basically, what he gave was the yes, you are right. So this is popularly known as Shannon theorem. So Shannon and Hartley theorem we call it. So why I am telling this, because I'll be talking about it while I proceed in the session. So Shannon theorem basically is like capacity of wireless channel in terms of data rate. Just a moment. Sorry, there was some disturbance. So capacity of a wireless channel in terms of say data rate depends upon the spectrum, how much channel bandwidth we have, right? For example, if you look at 2G, our channel bandwidth was 200 kilohertz, 3G we had 5 megahertz channel bandwidth and so on. So if you increase the channel bandwidth, overall capacity of the wireless system will also increase. In addition, it also depends upon the signal to noise ratio. So that like if you go away from the transmitter, your noise will increase and overall capacity at that point will decrease. So that means this also tells you about how much area you can cover with certain speed. Right? If you're nearer to the transmitter, your speeds are better. If you go beyond because of the this particular log2 1 plus SNR signal quality, your uh, data rate will increase. One additional thing which we have added here is the antenna. As we know that if I have multiple antenna, I use MIMO concept. So I can increase the overall capacity of the radio channel. Original Shannon theorem was not having it, but we have just added to tell that with number of antenna also we can actually increase the overall capacity of a radio. Now, this gentleman, do you know who he is? Okay, he is Gordon Murray, you may be knowing, and you may also be knowing Murray law. What it says that every 2 years, roughly every 2 years, the number of transistors on microchip will double. That means whatever devices we have, whatever form factor devices we have, uh, uh, the capacity, the compute capacity or the memory will double. So that means I can have more capable phone in the same form factor in every 2 years. This is true not only for mobile phone but also for the towers, VTSs, our computers, servers, laptop, everywhere. So, and his law is still valid, more or less valid, that it's happening every 2 years. We have more compute, more power in the same form factor. Okay, so now let's come to the mobile communication. So earlier we talked about a wireless communication by Marconi in 1896. Now let's look at what kind of mobile telephony we started. So this was an era of 40s, 1940s, when some sort of mobile communication was launched. It was kind of a Bell Lab in USA, and we are no, I mean, saying this as a 0G, although there is no such concept because 1G started in 80s, so I'm calling this as a 0G. So Bell Lab, what they did, they created some sort of mobile communication, and in that the receiver used to be in a car, right? So it was some sort of a car phone. You can install that particular mobile phone in a car, and the radio part which used to be installed in the car used to be very heavy. 80-pound radio used to be placed in the car, and it was driven by the car battery or additional battery which can be placed in the car. uh, so it'll look like this, something like this. I have taken these pictures from AT&T Bell Lab website, etc. So it was not a pure mobile. Why I'm saying that? Because the part of the I mean, your voice used to be carried wirelessly from this car to the nearest tower, and from that tower it is to be carried on a PSTN line, the landline telephone. It is to be carried, uh, and as we know that the landline telephone at that point of time was operator assisted. When you lift your phone, some operator will uh, answer, and then you ask to connect to certain individual or place, and it used to be connected manually. So here also same thing will happen, that on wireless part it is radio. Beyond that it was operator assisted. So operator will connect to wherever you want to uh, call. So the first time it was demonstrated by Bell Lab in June 17, 1946, and they actually continued evolving this mobile communications and adding new feature and enhancement. Initially, what they used to do is erect a tower on top of a hilltop, so that it covers a radius of about 20 mile, that is 30 to 33 kilometer. And from a mobile tower, it will connect to the nearest PSTN exchange on a wired kind of a connection. And this area of coverage used to be called mobile service area or MSA. But the problem was that the receiver which we had, the trans receiver which we had in the car, uh, whatever transmit power was there, it was not able to reach out to this tower. So downlink direction, it was fine, but uplink direction, there was a problem. So what they did was they installed more number of towers where uplink traffic can be wirelessly given from the car, uplink to this tower, and from this it used to go to the landline. So they had a single tower for say downlink direction transmit, and for receiving they had multiple number of smaller tower across the route of road, or maybe if they are covering cities, so more number of such towers. Initially they were given, FCC had given only three channels of 30 kilohertz in lower band, but over period of time, like if you look at the chart on the right side, initially then from three channels they gave about 10 channels from the 35 megahertz uh, band, and then later on 11 more channels from 150 megahertz, and then 12 more channels from 450 megahertz. I'm talking about from 1940 to 1950 and beyond. So it evolved, and now they had 33 analog channels of 30 kilohertz each to carry the mobile telephony. And this was in US primarily. Other countries were also kind of experimenting in a similar way, but Bell Lab thing was most popular. And there was no concept of frequency reuse. As we know that 2G, in 2G era, we had a concept of cellular cell, and also concept of frequency reuse. But in 1946, early mobile telephony, we didn't had concept of uh, uh, reuse of frequency. But like suppose if you use three channels in one MSA, three more channels in other MSA, and if you want to reuse this frequency, you could have reused only after 100 mile. That means about 300, 400 kilometer away. So almost it was some sort of negligible reuse of the channels or the frequency which we had. And that's why overall capacity was very, very limited. For example, in one MSA area at a time only, they were able to put only 3 channels. So 3 customers can only talk to. So that was the limitation. Uh, what I'll do, I'll share some video by AT&T Bell Lab at that point of time. They had created, not run this here to save time, but I'll share the link in the WhatsApp group. All of you can just look at this video and see how the 1G telephony was conceived and was operating. This is the link also there in the PPT which I have shared. You can also see this video through this particular QR or the link given. Okay, now let's look at evolution from 1G to 5G. In the next slide, the pictures I have taken from one of the white paper of Qualcomm, which is very nicely explained the evolution. So if you look at 1G era, so 1G era started in 80s. It's not exactly 1980, but during the 80s, maybe 1978, 79, 80, 81. That period was period for 1G communications. And as we know that there were a lot of technologies uh, uh, being rolled out in different countries. There was no single standard worldwide. For example, in USA, they had a technology called AMPS, Advanced Mobile Phone Service. Nordic countries were having NMT, Nordic Mobile Telephony. And then Japan and some other European countries were having TAX, Total Access Communication System. So basically, different technology at different uh, uh, countries, and it was purely a voice, analog voice kind of a communication. So some sort of mobile, and it was really good. So I'll talk about that later in slightly detail. Now, exactly after 10 years, from 1980s to around 1990s, the 2G mobile communication started. So here also we had many technologies. For example, the AMPS of the Bell Lab was also kind of evolved to digital AMPS that was called 2G. And from European, like there was an, you may already be knowing, the ITSI evolved a standard called 2G or GSM, Global System. May I request all of you to kindly keep your mic mute? Please, please mute your mic. Thank you. So the 2G was a digital voice. So we use digital technologies to launch 2G, and primarily, in addition to digital AMPS and GSM, there was also a technology called IS-95 based on CDMA. So these were two, three technology, but what succeeded was GSM, as all of us know. So we call it efficient voice to reach billions, because this was, GSM was one of the most successful technology which still exists in very many part of the world, including our country. Now again, after almost 10 years, in year 2000, we had 3G. So during 3G time, also we had many technologies. For example, from GSM evolution, we had WCDMA, or we also evolved to HSPA and HSPA plus. And from CDMA side, it was EVDO revision A and revision B, which was kind of a 3G technology. And during the 3G era, actually, the focus was on mobile data, some sort of wireless internet, some sort of wireless internet. I recall that having 3G dongles, right? Then again, after 10 years, around 2010, we had 4G technology. This time, the technologies, again, there were more than one technology. One technology was evolution of GSM, WCDMA into LTE, long-term evolution. And various version of LT advanced, gigabit LT. In addition to this, there was one technology called WiMAX. The 16M version of WiMAX was approved as 4G technology. But what succeeded was LT. LT, whatever 4G communication which we have today is nothing but LTE today. So in LTE, it was some sort of mobile broadband, right? Mobile broadband. That means now we had a very good data rate onto the mobile itself. We were able to do everything which I can do from a laptop, from a mobile itself. So that was the thing which came with 4G. So again, after 10 years in around 2020, in some country, they started in 2029. In our country, we started in 2022 is the 5G technology. So here, what changed from 1G, 2G, 3G, 4G is like now this 5G communication is not only for smartphone or we human, but also for machines. And a lot of new technologies came that can be edge, that can be network function virtualization, that can be slicing, and it have use cases for all sector of economy. So to summarize this evolution from 1G to 5G, what you can say is that mobile technologies is continuously evolving. And then every 10 years, next generation of mobile technology evolves. And thirdly, every next generation has brought over 10x increase in capability, right? So that is about the evolution in short. Now let's go to each generation of mobile technology in slightly detail so that we have some better idea. Okay, so as I said that 1G came during 80s, and I'm talking about AMPS here because I'm not talking about NMT and tax. It would be similar, but just to have an idea that during 1G time, the spectrum band which they were using was 900 megahertz band. Later on, that was also used for GSM. In some other country, they were using 800 megahertz band. So band wise, it is the lower side of the band. We also call this low band. And access technique which they used was FDMA. When I say FDMA, that means they will uh, have a smaller chunk of the frequency band that was 30 kilohertz. You can see in this picture that uh, we using FDMA, frequency division multiplexing, they divided into a small chunk, giving some sort of a guard band between the two channels. So as you see that channel bandwidth is 30 kilohertz in 1G, the channel bandwidth is 30 kilohertz, and it was again analog kind of a communication. And the modulation which they used at that point of time was frequency modulation. I mean, today we have FM radios using the frequency modulation technique. At that point of time, this was used for mobile communication, 1G mobile communications, and services offered was only analog voice, right? But the good part was that the concept of cellular, that hexagonal cell, started during 1G, and also concept of reuse of frequency. For example, in this particular cell, suppose the green cell which you are seeing, so they are deploying more than one uh, channels, right, of 30 kilohertz. So these, suppose channel A and channel B, these will be apart. Like for example, if you see uh, below picture, if A is say one channel, the second channel in the same cell would be the B after leaving six channels in a continuous way if you divide. So I can have more number of channels, but those will be away about six channel away, and then I can reuse this A and B after 3, 4 cells, right? The reuse concept, which uh, popularly known in 2G, was actually started in 1G. Okay, so the picture which you see is a real 1G phone. It was Motorola made. So Motorola, there was some other company also. This is looking like just a cordless phone which we use today, but this was 1G mobile communication. And it was The mobility was also available to some extent. Like if you go to any area covered by this, whether you are in BTS 1 area or BTS 3 area, you will be able to communicate. But handoff and all was very, very primitive and it was not working, although they worked upon that. And it used to be connected to the PSTN or landline. The system used to be connected to the PSTN because majority of the customers were on the PSTN. So we can conclude that 1G is some sort of foundation of mobile communications because all the concepts started here. And it was an analog technology and analog voice we used. The voice quality was poor being analog, and also the phone size compared to today's phone was very, very large. And the problem was that the battery of this phone will discharge in after using 1 hour or 2 hours, and then you have to recharge it again, and it will take a longer time. The overall capacity of the system was limited because there was no I mean, overall capacity was limited being analog technology. Reliability was also poor because there was no encryption used onto the channel. It was plain. So anybody who can build a trans receiver on that particular spectrum using the FM techniques will be able to decode and hear the voice, can actually intercept. So that's why we say that the security or reliability in that sense was very, very poor in 1G network. Again, AT&T, their archive has one video which really explains this 1G technology. So here also I'll give you the link and you can go through later. I'll be not running here. Okay, now let's look at how we evolved from 1G to 2G. So as we know that in 1G we had 30 kilohertz channel bandwidth in 1G AMPS. So during 2G time, as we discussed that GSM technology came. GSM that was from ITSI. ITSI made a standard of GSM around 1990s. It was initiated in the Europe itself. So the difference was, although I mean AMPS evolved to digital AMPS, but the successful technology was GSM. Let's talk about the GSM. So as we see that the channel bandwidth in GSM is 200 kilohertz. Please recall that in 1G it was 30 kilohertz and here my channel bandwidth is 200 kilohertz. So that itself, as per Shannon theorem, which we saw, overall capacity of the wireless channel will increase. On top of this, uh, we are using TDMA, time division multiple access. That means this 200 kilohertz channel will be divided into 8 time slots. So uh, theoretically, what will happen is like simultaneously 8 users can use this 200 kilohertz channel. So basically, we are using combination of FDMA and TDMA in GSM. So overall capacity would actually increase. Of course, there will be some of the time slot used for control signaling. So effectively for voice, there will be less, maybe 7 or 6 time slots in one 200 kilohertz channel. In addition to this, at that time during 90s, a lot of compression technique also came into being. So as we know that uh, our voice is the data rate of our voice is about 64 kbps, which was used in landline telephonies. So, but to save the radio resources, what was done was to compress, we call it voice encoding. So using the vocoder, the 64 kbps voice will be encoded to a 8 kbps voice, and generally there will be no deterioration in the quality of voice. So on the air interface from BTS to the users, the voice will be encoded in a 8 kbps 8 and one time slot since can offer about 13-14 kbps of the data rate. One time slot in a 200 kilohertz channel, we were able to carry this 8 kbps voice onto one time slot. So the the use of compression also increased overall efficiency of the 2G system. The concept of cellular was borrowed from 1G. Concept of frequency reuse was also borrowed from uh, uh, the 1G itself, right? So frequency reuse continued in the 2G system. How many of you recall this particular phone? You can speak if you want. So this
Sir,
is Nokia.
Nokia phone, sir.
Yes, yes,
Nokia
you are
phone.
right. Yeah, so it's
That
Nokia
was the
33,
first. Huh.
correct. So Nokia 3310 phone. Later on, they came out with many models. So if you look at 2G network, let me show you the 2G network. So it will look like this. I'll not go much into detail, but we'll just in a very short, I'll try to explain. So from the user side, you have a mobile phone and then you have a SIM. SIM is some sort of subscription we buy from the telecom operator. This is completely different from CDMA system where the phone itself will be bundled. There is no separate SIM initially. Later on, they also added SIM. In GSM also, some of the country would have bundled connections being given, but primarily as per standard, any SIM can be inserted into any 2G mobile phone. So on to the mobile side. Onto the radio side, we had two component. One is the base transceiver BTS connected to base station controller. So basically, BSC controls multiple number of BTSs, and then this will get connected to the core. So the core will consist of mobile switching center, which will connect all the BSCs. And then we have gateway MSC, which will connect to outside PSTN network. In addition, we had other network function called home location register HLR, visitor location register VLR, authentication center, and so on. So these were the network function during the 2G era. So to summarize, what we can say that our 2G network offers digital voice, uses digital technologies compared to analog technology and analog voice in 1G. And then system capacity has increased because of using 200 kilohertz channel bandwidth instead of 30 kilohertz, using TDMA where I can have 8 time slot on 200 kilohertz channel, using the vocoder, and also using the frequency reuse concept. I can split the cell and have more number of BTSs in the same area. So I have a question that can you tell me two great feature of 2G which made like very popular GSM mobile communications? Can you guess the two very key services from the I'm not asking from the technology perspective, I'm asking from the user perspective. What were the two main feature which user liked and it was very useful for all of us? Any one of you can
Uh,
open the mic. Yeah.
Multimedia
S
communications, sir.
SMS,
And charging.
SMS.
Charging.
SMS.
SMS, sir.
Yeah, very right. So SMS was one service which really some sort of data we had, and I recall using SMS services on every festive occasion. Used to, I mean, our SMS inbox used to be flooded during Holi, Diwali, and other festivals, which is happening today in WhatsApp, right? The second major feature, if somebody can tell,
Charging. Charging.
Mobility.
that you can see on the screen, the third point which I have made, that is the mobility means uh, so multimedia was not 2G. In fact, I'll come to that. Mobility I'm talking about. Mobility means even if you have a Nokia 3310 phone and if you go to any other geography, other country, your phone will actually work. And this is all because GSM technology was based on standard. The spectrum used was also standard 900 megahertz and later 1800 megahertz. So all the phone will follow the same standard. So you can the roaming facility or the mobility facility. One is the mobility when you move from one base station area to other base station area. Other mobilities, even if you go to other network, maybe other country, other place, your mobile phone still work. So that is really good, and that is the USP of mobile communication today. That why mobile communication is very popular because of the aspects of mobility. wherever you go in your network, in other network, one country, other country, our mobile phone still works. So that's the uh, that was actually invented during 2G itself. It was tried in 1G, but it was really used in uh, 2G time. And SMS, some of you have already spoke about. So later on, we call it 2.5G. It's so not 2G, but 2.5G when GPRS was introduced. So you may recall that some sort of data we started with the GPRS, and then later on we evolved to Edge, and we call it 2.75G. So basically, the multimedia which we are talking about was 2.5G and 2.75G with introduction of GPRS technology and later on edge technology into the 2G network itself. So the pure 2G network was not able to support this data. What was required was to have separate component in the core side to support data as 2.5G or 2.75G. That was SGSN and GGSN, we call it. So basically, it's nothing but serving GPR support node, serving GPRS support node and gateway GPRS support node. So this was nothing but to support the data call onto the 2G network. And of course, there was some software upgrade into the BTS PSCs and MSC, which could have been done uh, from the core network itself. So that was kind of a 2G network. Now let's look at how we evolved towards 3G. So when I say 3G, the one thing which happened is the channel bandwidth. Channel bandwidth increased to 5 megahertz. In 1G, if you recall, it was 30 kilohertz, 2G 200 kilohertz. In 3G, it is 5 megahertz. So how many times? Almost 20 times bigger channel bandwidth. So that's how, if you look at Shannon theorem, the overall capacity will definitely increase. In addition, what was used was the CDMA kind of a waveform. Wideband CDMA, we call it wideband because I'm using 5 megahertz channel bandwidth. So wideband port division multiple access was the kind of a waveform which we used. And this was also called UMTS. Okay, and this was actually leveraged on top of the GSM network itself, right? And this came around 2000, as we know. Later on, this WCDMA evolved to something called HSPA, high speed packet access. This is nothing but using certain higher order modulation and other things, right? So HSPA was part of the 3G. And it was for the first time that uh, the standards were made by 3GPP. So that during that period itself, third generation partnership project was, I mean, came into being. 3GPP is nothing but consortium of many other standard developing organization from other countries. That is, it is ERIV, ITSI, uh, GTA, and so on. And also there are other members. So this was actually formed, this consortium was formed to have a single mobile standard for the world. And the 3G standard was the first standard which came. They had also adopted the GSM technology and keep evolving that also, but primarily they started from the 3G onwards. Let's look at how. So if you look at this picture, what this picture says that out of the 5 megahertz channel bandwidth which 3G is having, the preference is given to the voice customers, and only after serving all the voice customers, whatever capacity is left is actually used for data. So that's kind of a concept which we have in 3G. So 3G itself, so if you look at uh, the requirement of ITU for 3G. So as we know that requirement of mobile technology 3G onwards is given by ITU. So ITU had said that in 3G, the peak data rate, if you are stationary, can go up to 2 Mbps, and the data rate a mobile customer would have is about 384 kbps, right? So it was a very less requirement for 3G. But when 3GPP was developing standards, so they evolved beyond ITU requirement. They evolved beyond ITU requirement. So for example, they used higher order modulation. So for example, different QAM they use. So as we know that in QAM 4, I can transmit 2 bit in a particular symbol time and in particular duration. But if I use 64 QAM, I can use how many bits? 6 bits onto the same frequency and time resources. So 3 times increase. So that way, using higher order modulation, uh, we were able to have more and more speed. So we evolved to 14.4 Mbps, and later on we started using carrier aggregations. That means I can use 3 different carrier having 5 megahertz channel bandwidth. So my aggregated channel bandwidth will be 15 megahertz. So my capacity will also become 3 times. So we could evolve up to 63 plus Mbps. So, and that's why we called it HSPA plus. So in 3G from WCDMA, which was supporting 2 Mbps max speed in a stationary environment, we evolved to HSPA that we had 14.4 Mbps. Then we evolved to HSPA plus, that is 63 plus Mbps. Let's look at different evolution of 3G. These are 3GPP releases. As we know that 3G started with release 99, and later on after release 99, they started naming it as a release 4, 5. So if you look at release 5, it was HSDPA. In the downlink direction, they increased higher order modulation and they could achieve 14.4 Mbps of downlink, but uplink was again 384 kbps. In release 16, they worked upon uplink direction. In uplink direction, that is HSUPA, high speed packet access for uplink. U is uplink. So uplink direction also from 384 kbps, they enhanced this to 5.7. In release 7, using some technique, again they increased the capacity, 28 Mbps, and so on. So if you look at, they were continuously evolving. But look at this release at 8. So this was the time when LT also came. So release 8 is also our 4G LT release, right? So what operator did was, like, wherever they were, they actually adopted 4G from release 8 onwards, and they might not have used the subsequent releases of 3G. Maybe some country have used, but majority of them, they actually migrated towards 4G. That's why we see that life of 3G was less compared to 2G, which is still existing, right? So that was kind of different releases of 3G. And if you look at the network, okay, before that, let me show you this. Do you recall what this phone is? Can some of you recognize this phone?
That Motorola,
BlackBerry, sir.
BlackBerry Motorola.
Yes, very right. This is a BlackBerry phone. I mean, during the 3G time, this BlackBerry phone came and they started offering bundled email services, or they used to say secure. So all high-end fellows would use BlackBerry phone initially. During that time itself, even the Apple came out with their first mobile phone. Earlier, they were into, if you recall, iPod music systems they had. Uh, it was for the first time that they came out with a mobile phone, Apple, during the 3G era. Okay, so if you look at the network, so network of 3G is, as I said, that it is some sort of evolved from the 2G itself. So on the devices side, of course, you'll have a 3G device and separate SIM subscription from the operator. Now this particular, we used to call BSS in 2G. Now we started calling this as a RAN, radio access network. This terminology started during the 3G era, and BTS is now called node. right? And BSC is, we call it radio network controller. So basically, functionality wise, more or less, it will be same, but there is some evolution happened. Onto the core side, CN side, now I have two different domain, right? So one is circuit switch domain. So this is straight away borrowed from 2G. So whatever we had, MSC, GMSC, and so on, that was used for circuit switch domain. That means all our voice call will be handled here. And all our data call. So whatever we did in 2.5G and 2.75G onto the core side, SGSN, GGSN, we took onto the 3G core network. So now 3G has got two different core, packet switch domain and circuit switch domain, and rest of the element would remain same. Even the IMS thing came during the 3G period, and then it gets connected to internet or any IP network, and for voice call to PSTN or circuit switch network. So this was a broad network. So if you look at, if you summarize, yes, it offers digital voice and SMS as was there in the 2G. Mobility, yes, coming from 2G. SMS also is coming. The new thing which came is the mobile web browsing. If you recall, during 3G time, we are using web kind of environment to surf onto the website on the mobile itself. And then uh, the radio side, it was WCDMA, wideband CDMA, and as ITU had suggested, the speed was 384 kbps, but for stationary 2 Mbps. It evolved to 7.2 Mbps, then to 14, and it went on and went on with HSPA and HSPA plus. So HSPA plus was called 3.5G, not 3G, 3.5G. And what has started during this time, that our mobile phone used to have camera, right? And also the GPS that was embedded onto our mobile phone. So there was a service launch which was called MMS. So you can share the multimedia, right? During the 3G time or 2.5G or 2.75G also, you can say that MMS services was started by our operators, and we could share images and all. So that was image sharing. Then there was a native video call function in the 3G phone. So one can call other 3G customer on a video call. So that started. It was not like WhatsApp call. It was a native video call. And the GPS which started. Some navigation service was started during the 3G time. I recall using Nokia navigation system in Mumbai and some other cities they were offering. Okay, now let's look at evolution towards 4G. So in 4G, again, the channel bandwidth increased from 5 megahertz in 3G to 20 megahertz in 4G. And the waveform is also changed from WCDMA. Now I have orthogonal frequency division, multiplexing and multiple access. So that is one. The other thing what happened is like we started using MIMO as a mainstream. That means every 4G phone will at least have 2x2 MIMO. So uh, any 4G phone as per standard will have 2x2 MIMO. That means using the same say 20 megahertz spectrum, I can transmit two streams of data, and I can on the receive side also I can receive. So overall capacity or data rate would theoretically double. It may not double practically, but theoretically double. The other use case of using MIMO is to make uh, the overall path very robust, in the sense that if I transmit same data stream from the both antenna, so my I can cover slightly more, and also I'll be able to recover the errors, and so that my channel will become very, very robust. So that was the use of MIMO in 4G. And the third, uh, the practical thing which started happening is the use of carrier aggregation in 4G. So if you recall, release 10 of LTE, it was supporting carrier aggregation of 5 such carriers. So if I have a one carrier of 20 megahertz, so overall aggregate channel bandwidth will be 100 megahertz, right? So later on this was also evolved, but practically operators used carrier aggregation up to 5, that is release 10 was used. In our country, since operators were not having more channel bandwidth, they were having only about 20 megahertz, and they were having some other spectrum in 900 megahertz, very small. So they used carrier aggregation, but effectively they didn't had 100 megahertz at any point of time. That's why the 4G speed in our country compared to other countries has always been less. Okay, and what other things started happening is, like, if you look at earlier technology, the technology which were using lower side of the band, they were primarily relying on FDD, frequency division duplexing. So that means you have two distinct spectrum, one for uplink and one for downlink. And that was a kind of environment even in 2G and other technology which we were using. But from the 4G, the TDD came as a mainstream. In addition to FDD, TDD came in a mainstream, right? So now I can use a single spectrum, or we call it unpaired spectrum or asymmetrical spectrum, used for uplink and downlink both in a, that will be divided among time. Can some of you tell me what is the benefit of using TDD? Some of you can open the mic and tell what are the benefit of using.
Different times we can send same frequency.
Okay. Any more answers?
Channel reciprocity.
Okay.
Better is
Sir, in other slot, mobile station can be in the sleep mode.
Okay.
So that we can.
One of the important benefit which I see normally when we use any mobile, mostly we are downloading the data, and uplink the utilization is less, right? So if I use time division duplexing, I can allocate more time for downlink and less time for uplink. Whereas if I use TDD, I use same chunk of spectrum for uplink and downlink. So many a times my uplink side spectrum is unutilized. So I have less efficient use of spectrum when I'm using FDD, and very high spectrum efficiency use when I'm using TDD. That's the difference one of the major difference I see. Okay, so how it evolved towards 4G? So 3G, we saw that I have a circuit core, I have a packet core, right? And in 3G, since data rate was limited, so BTS to RAN connectivity from the node, we call it node E, to the radio network controller. We used to have E1 backhaul or T1 backhaul, right? 2 Mbps or multiple of 2 Mbps. Whereas if you look at 4G, so from two core, circuit core and packet core in 3G, now I have only the packet core, right? I don't have the circuit core. There is no facility for voice communication per se natively in a 4G network. And now instead of having a sort of T1 backhaul, I have some sort of fiber or a higher capacity kind of a backhaul in 4G. Other difference, as I said, that I don't have really a circuit core, so I cannot support voice. In case I need to support voice, I need to have a system called IMS, which will offer the voice services. And that is also called voice over LT or VoLT. All of us may be aware of. So let's look at the network. So now network evolved to a flat network. So what is the difference which has happened broadly from 2G, 3G? So from device side, of course, you'll have a 4G phone, the supported phone, and subscription as a SIM coming from the network. We also started concept of eSIM during this time. Now on to the radio side, the RAN side, radio access network side, the change is now I don't have two different component. Like in 2G, I had BTS and BSC, 3G, I had node and RNC. Here I have a single entity called eNode B. Right? eNode B. So that means BTS and BSC functionalities are clubbed together, or node or RNC is clubbed together into eNode B. And to support handover between one BTS to other BTS, all the neighboring BTS are connected to each other on this is called X2 interface. This is mainly for handover from one BTS to other BTS. So we call this entire system as an enhanced UTRAN. You may be knowing the full form and all. And the core side, now we call it Evolved Packet Core or EPC. This has also been made very, very flat. If you look at the dot dot which you see, dot dot connection are control signaling, and this thick connection is for user plane data. Whatever as a user I am uploading or downloading, that data path is this one, the dark one. Okay, so onto the control side, please note that we have mentioned only the key component here. There are many other network functions of 4G. The most important is MME, Mobility Management Entity. So basically, mobility management, session management, security related aspects, everything is taken care by MME being a control network function. The data path or user plane data flows on this S1U interface. So that is from your E node B goes to something called serving gateway. Serving gateway connects all to all the BTSs. And then towards the outside network, internet or IMS or any other, the PDN connects, packet data gateway connects. And between serving gateway and PDN gateway, we have an interface called S5 and S8. Can some of you tell me that in which case I use S8 interface and which case I use S5? Okay, in a roaming environment, I use S8. Suppose a user is roaming in some other network. So this serving gateway will connect to, say, packet gateway of the roaming network. So there we call it S8 interface. There is slight change. And there are many other interfaces you can see. HSS is kind of akin to the HLR, home location register. And now we call it home subscriber server in 4G. And then you have policy charging function, and there are many other functions which are not shown in this. So to summarize, we can say that the 4G is a data only technology. To support voice, I need to have IMS separately. And yes, voice over LTE is supported, that is through IMS. And do you recall that when Jio launched their 4G services, they were offering their services free of cost for almost 1 year. Do you know the real reason why they were offering free of cost? Any of you?
There no extra bandwidth required to transmit the data.
In fact, they did not had VoLT support in their system, and voice was not a service for them at that point of time, and they were still working on that. So that's why they offered their services free of cost for almost 1 year plus. And by that time, they actually they were able to commission the IMS and test voice over LTE, and then they started charging 1 Gbps. My next question to all of you is like, what happened to Airtel? Airtel also launched 4G, but they didn't give anything free of cost, and they also did not had voice in their 4G network. So how they were able to support the voice services onto their 4G network initially? Any guess or any answer?
So because they were on the backbone network of 3G, so
Very
that's why
right.
they were charged.
Very right. There is a concept called circuit switch fallback, which 4G supports. So what will happen is that if you are in a 4G network, you are latched to 4G network, and if you try to make a voice call, so you will be redirected to their 3G or 2G network. You can make a voice call, and then automatically after voice call is over, it will come back to the 4G, right? So that facility they had, and later on they also installed or commissioned VoLT system, and then Now both operators are having VoLTE in their 4G network. The mobility, of course, there SMS. Here the change is mobile broadband. So mobile itself has become very high data speed giving device, and so high data rate. The phone has become very smart, as we know. A lot of hardware has become mobile app, be it our watch, be it our many physical thing, radio, etc. has become a simple app in our mobile phones, and the advent of social media, very high consumption of video, and so on. So that was some sort of about 4G network. Now let us talk about what were the capability of 4G radio or 4G network overall. Just to summarize, in terms of peak data rate. So peak data rate of 4G was 1 Gbps, right? 1 Gbps, but this is only possible when you have about 100 megahertz channel bandwidth. That means you are able to aggregate 5 number of 20 megahertz channel bandwidth and have 100 megahertz. Then only an operator can achieve peak data rate of 1 Gbps. The second important parameter, we call it spectral efficiency. What is spectral efficiency? Any of you? So spectral efficiency is nothing but in 1 hertz of the spectrum, how much data rate one can achieve. For 4G, it is 10 bit per second. And that's why with 100 megahertz into 10, you'll be able to achieve 1 Gbps. And the user experience data rate is 10 Mbps. When I say user experience data rate, what I mean is that when I go to edge of a network, then also I should get at least 10 Mbps. And when I come near to the base stations, I have more data rate, and near to peak data rate I achieve. So practically in our 4G network, when you do some sort of speed test, we get about 30-40 Mbps. All of you may agree about it. And the latency theoretically supported is 10 millisecond in 4G. Practically, it is not coming 10 millisecond in all cases, about 20, 15, depends, right? Okay, now let's very briefly touch 5G as an introduction. So as I said that 5G is not only supporting smartphone, but also supporting use cases in different sector of economy. And that's why we say that this is also for machines. This fifth generation of mobile communication is some sort of a generation for machine to machine communication also, so that this 5G technology will be useful for we people, businesses, society and all. So overall high level system of 5G as is there for 4G or 3G is like this. So now we are, if you recall, we were showing only mobile phone as a user equipment. In 5G, we are showing car, drone. It can be any object, any machine, which is now called user equipment. And the radio is called now NG-RAN, Next Generation Radio Access Network. We also call it NR, new radio, and other terminology is G Node B. From E Node B of 4G, now we have next generation Node B, Z Node B. So that's the radio part. And then the core. So similar to other cores, we have a 5G core. And then we have a data network. So just see the difference. Here we are calling data network. In 4G, we used to call packet data network, PDN. Here we are calling data network. Can you guess what is the region we are calling data network and not packet data network? Any of you? If you are aware, please let me know. So 4G supports only IP type of data, whereas in 5G I can support any other structured and unstructured data. And that's why we call it a pure data network. It can be IP data network like internet, or it can be any other server supporting any other kind of a data other than IP data. So that's why we call it data network in 5G. compared to packet data network in 4G. Okay, if you look at architecture, 3GPP has given two kind of architecture for 5G. The one is called reference point architecture and other is called service-based architecture. The picture which you see is a reference point architecture. Why we call it reference point architecture? Because the network function are connected to each other on some particular interface. For example, the access and mobility function connects to session management function on N11. Similarly, session management function SMF connects to user plane function on N4 and so on. So these are reference point architecture. So they have a different protocol for to talk to each other, right? So that's the reference point architecture of 5G. We'll talk about this in more detail when we talk about 5G core architecture later when we have that. The other I said is the service-based architecture. So basically, practically all the deployment which is happening of 5G is a service-based architecture. So why we call it service-based architecture? Any guess or any idea? Some of you, if you want to tell me that why we call it service-based architecture? You can open your mic and speak, please. Any answer? Am I audible or not?
You are audible,
Yes,
sir.
You are
Okay.
audible, sir. But
Okay.
answer, many of we are not aware of that answer.
Okay. No problem. No problem. So basically, the service-based architecture means the network function. For example, if you look at AMF, this one. So the AMF is some sort of service providers, like, so a network function can be a service provider and other network function can be a service consumer. Okay. So a network function may be service provider as well as service consumer. So that's why we call it. So you may remember that, that nowadays there are many API based services which we use in IT world. So those are service based, right? So they offer, you might have heard about RESTful API, wherein you give some request and you the other network function is provide that service kind of. So because of that, we call it service based architecture. And what other difference is that compared to 4G, in 5G, the user plane part where user data flows has been completely segregated from the control plane, the top part, right? And so we have segregated user plane and control plane completely. In 4G, the network function was like they were also handling user plane and control plane. And that's why the problem in 4G was that all the network was sort of centralized. Even if you make a call from one person to other person nearby, the call will go to their core, which is located at a centralized location, and then it will come back. In 5G, what will happen is that all the user data, suppose you are wanting to access internet or any other service from your local place itself, local city itself, the call will go to the data network, which can be internet, which can be voice and all, right? So that's why the benefit of user plane that the local services are provided at the local city itself. And the user plane part of the 5G can be located near to the user. When you locate this particular thing near to the user, latency improve, right? Latency will be better, and also backhaul requirement up to the core will actually reduce. And then the network functions are talking to each other on API, application programming interface. You might be aware of RESTful API. So it's not point to point connection. It is some sort of API call which they make to talk to each other, just like an IT system which you have. Even outside, for example, any operation support system or any other third party services are to be connected. those can also be connected on API. So basically, there is a network function called NEF, network exposure function. So through this, outside services can be connected, right? So we have outside connection also on API. Most important aspect is every network function is now a piece of software. We call it virtualized network function. So that means I have segregated hardware and software. Now I can buy hardware from any vendor, any server vendor, and deploy this network function. Even I can deploy on a cloud native infrastructure, right? So on the cloud also, this network function can be deployed. In fact, there are open source 5G core available, and you can even deploy on your PC or laptop. You can hypervise your device, and a miniature of 5G core can be installed on your laptop and desktop. So that's the beauty of 5G. If you compare 4G and 5G, like in 4G, I had MME, Mobility Management Entity, that is now divided into two parts in 5G, AMF and SMF, access and mobility function and session management function. Similarly, the serving gateway and PDN gateway is combined in 5G, and now it is user plane function. So here we had a PCRF in 4G. In 5G, I have policy control function. I have now separate AUSF and unified data management in 5G. Earlier, HSS used to do this function. In 4G, we had a concept of application function. In 5G also we have. Similarly, NEF is a new network function. Network repository function is the new one. Network slice selection function is the new one in 5G, because this is the requirement of a service-based architecture. We'll talk about this in detail later. So don't worry if you hearing so many terminology. Okay, so with these, we can have many 5G use cases. So 5G has three broad usage scenario. One, the first we call it enhanced mobile broadband. Second, we call it URLLC, that is ultra reliable, low latency communication. And then we have massive machine type communication, MMTC. And with these three, we can support many use cases in different sector of economy, be it public safety. I'm talking about police, I'm talking about fire, I'm talking about NDRF. So they can use 5G services. Then in agriculture sector, a lot of use case is possible. We can connect a whole lot of agriculture sensor and use it. In health sector, I have use case, transport and logistics sectors, and then education sector, entertainment sector. You name any sector, I can have 5G use cases in that because of the feature I have. So we'll go into depth of these use cases later in other session. Now, what are the different technologies? Just for recalling name, we will just list it out and we'll go into detail later in the sessions. So in 5G, I can go up to 400 megahertz channel bandwidth, that too in FR2. But yes, from 20 megahertz in 4G, I can go up to 400 megahertz. Then I can also use frequencies in millimeter wave, that is 28 gigahertz, 39 gigahertz, and so on. And then there is a concept of massive MIMO. I can embed thousands of antenna in a small form factor. So that's why we call it massive MIMO. And then we can form a beam, steer a beam. There is a concept of, so please don't worry about the new terminology, but just for your awareness, I am telling all this. We will be talking about each of these. We'll have a separate session on all these aspects later in the classes. So bandwidth part, and then we have a concept of Open RAN, and then network function virtualization. I talked about that all the network function in 5G is a kind of a VNF, a piece of app. Okay, and then network slicing we will talk about, and then edge computing. There's something called IAB, integrated access and backhaul. There's something called sidelink. Sidelink is nothing but D2D communication. Then we also talk about satellite integration, AI ML coming as a native into the 5G network, and many more. these technology we'll talk about when we go deeper into the course in coming days. Okay, now let me introduce you to 6G a little bit, although we'll go a bit detail. So for 6G, ITU has come out with a requirement, right? So what that requirement is that in 5G, as I told you, that there are three usage scenario: enhanced mobile broadband, MMTC, and URLLC. In 6G, these are enhanced to immersive communication, massive communication, and hyper reliable low latency communication. So this is extension from 5G. In addition, there are three more new usage scenarios, that is ubiquitous connectivity that was got added by India, integrated AI and communication, integrated sensing and communication. So I have 6 usage scenario in total. In addition to this, I have four overarching aspect, or we also call it design principle. What are those? Sustainability, connecting the unconnected, security, privacy, resilience, ubiquitous intelligence, right? This diagram is coming from ITU papers. This is called wheel diagram. And you can see all these 6 user scenario and 4 overarching aspects, right? So if you go slightly detail, they have also released a diagram called Patlet diagram. What it says that the capabilities of 5G in terms of peak data rate, user experience data rate, spectral efficiency, right, connection density, mobility has been enhanced from 5G to 6G. So there are 9 enhanced capability of 6G which has been talked about by ITU in their paper. And then there are 6 new capabilities. These are like coverage, sensing capability, AI capability, sustainability, positioning, interoperability. These are the 6 new capabilities. Now what will happen is that based on these requirements, studies are going on that how much we should support. So there has been some target given in different countries, different SDOs are working on detailing of this, and maybe within 1 year time, ITU will actually freeze the real requirement of 6G. That's the process ITU follows. And the last slide, which I wanted to cover in 2 minutes, so it will be 13 hours now, that there are a lot of myth about 5G, that birds are dying or it has got impact on we human, etc. In a brief, I just wanted to, I hope that all of you would already be aware, but let me, for the sake of repetition, uh, let me break this myth. So as you can see in this picture, the spectrum from starting from very low frequency and going up to X-ray and gamma rays is divided into 2 parts, right? So the spectrum beyond visible light, that is part of ultraviolet, X-ray and gamma rays, these spectrum are called ionizing. I mean, the radiation coming from this spectrum is called ionizing radiation. And ionizing radiation is extremely harmful for us. So basically, they are able to break, like in our atomic structure, they will be able to break out the electron, and then your DNA structure will change of your cell, and then you may have cancer and all. So basically, the ionizing radiation is very, very harmful. That is coming from X-ray, gamma ray. But as we know that even X-ray is used in a medical field for a very, very small time. So there are more benefit than uh, uh, the harmfulness of the X-rays if you use in a low dose kind of, right? But the spectrum below that, below visible light, so that is our radio frequencies, microwave, etc., are called non-ionizing. So it do not have impact the way ionizing spectrum has impact. So that means the impact which you have is some sort of heating only. That too, if you have more power coming. So our frequencies in 2G, 3G, 4G, and even in 5G is within the non-ionizing zone. So we are up to 30, 40 gigahertz as of now, maybe up to 100 gigahertz as on date. So we are still into this non-ionizing zone. And since non-ionizing zone will not have impact the way ionizing radiation can have, so practically no problem as such. But anything in high power will be creating some harmful. For example, if you talk for a longer time, your ear get heated. So heating impact is there if you use it for longer time or if you use a very high power. So whatever power we use in BTS tower and whatever power we use in our mobile phone, those are in safe limit. ICNIRP is one organization which prescribes the limit, and that is endorsed by World Health Organization WHO. So with that, our in India we follow the ICNIRP guideline, and also our guidelines are much stricter from ICNIRP. So as such, and we monitor that also. There are mechanism by which we monitor. So as such, we don't see any bad impact even with 4G, 5G or other mobile communication. So with this, I close my session and we'll meet tomorrow. As per the timetable, you can look at the timetable and we can join. So in case you have any query, you can ask right now, or in case you want to connect me, you can take a screenshot sort of this particular page. I've given all my whereabout on mobile, Gmail, YouTube, Twitter, and LinkedIn in case you want to connect with me. So here are, you can take a screenshot here. So thank you so much, everyone. And maybe for everyone can actually open their video so that we take a picture of the class. So thank you so much, everyone, for attending the class. If you have any question.
Thank you, sir.
Okay. No
Can I
question?
ask one question?
Yeah, please go ahead, ma'am.
Sir, nowadays this DST has given one call for proposal. There is a quantum communication.
Yeah.
So quantum communication and 5G technology. Is
Yeah.
there any possibility we can club it and make it use of this classrooms, the recent hologram based classroom activities for language learning, Indian language learning concepts?
Yeah, very right. So we definitely have opportunity to use quantum in various communication technique, and most important is like uh, whatever encryption we are using in mobile communication. So definitely those are required to be made quantum safe, because somebody can capture the data today and using the quantum which may come tomorrow can actually decrypt your data taken from different places. So we must at least, even if you do not have quantum computing being implemented across all elements, but at least we should migrate towards quantum safe algorithm of encryptions so that our network is safe. That is one. And as quantum compute will grow, that will also become part of the any mobile network. So maybe in 6G, people are talking about implementing certain quantum related aspects onto the standards, maybe in 5G advanced and 6G. So yes, those would be the possibility. And I would request all the faculty members that if you are into research, you must participate and try to put your standard, whatever area you are working upon. And you also talked about classes where using holographic thing,
Yes, sir.
can it be made? Yes, it can be made. If you recall, our Prime Minister in India Mobile Congress 2022, he spoke to a small girl from a school using this holographic technique, right?
Yes, sir.
So you need to create an environment for teachers and schools
Hmm.
are possible. Even I mean, those are the things which will become very, very useful in case suppose very costly lab is established in one institution and other institution students want to use. Using this kind of a setup, those would be the reality in future. So yes, I mean, maybe within few years from now, we will see lot of such innovations coming into the market. And 5G and 6G will help in communication, right?
Yes, sir.
5G and 6G will help into the communications, right? So even without 5G and 6G using high speed broadband, these are a possibility. But if you want a mobility to create such environment anywhere, you need 5G and 6G kind of network. Another thing which 5G advance is trying to do is trying to make standard native standard to support AR, VR, XR, and
Yes, sir.
holographic communication. Because when we say holographic communications, you are taking images from various angle and then you're reconstructing. And then all
Right.
these information should reach to the destination or to the classroom simultaneously so that in a real time you are able to create that virtual environment. So you require a particular quality of service which is not there in the communication thing today. So we have
Yes, sir.
started talking about creating standard for AR, VR, XR into 3GPP standard itself. So once those are out, two things will happen, that it will improve overall experience of such things, and also it will be interoperable. See, there is a X service provider, Y service provider, Z service provider. Today, every service provider has got his own headset, right, and own services. I cannot use a Google handset and use the services of some other service provider, right? So that's the problem which you have today. With the standard, these would become interoperable. So I think that's the future we are talking about. Thank you.
Yes, sir. We
And
can add the AI modeling so that at the edge level itself we can build a model. And also
yeah,
we when we were studying this communication QPSK and all those things is increasing the capacity of those things.
correct. So you may already be knowing that in Wi-Fi 7 and all, they are talking about, I mean, they are already using 1000 QAM kind of a modulation. So, and in 5G also, up to release 16, we are able to use up to 256 QAM. And they have started talking about using 1024, 2048 QAM in subsequent releases. So yes, the order of modulation will definitely increase. Any more question, query, or any doubt or anything? We can talk any other topic also for 2-3 more minutes and then we'll break. Okay, so if there is no more questions, what I would do is I'll put a quiz, a very, very easy quiz on this evolution of mobile communications. The link I'll be sharing in the WhatsApp group, and all of you can actually try to attempt. So what I want to tell you is like those are timed quizzes. Once you start, within certain time it will close. So generally, if there are 15 questions, I have given 30 minutes. So I would request that once you are ready with, you can go through the PPT, which is I have already shared, or you can go through the recording, which we'll be sharing. After that, you can attempt, or if you are, I mean, very much confident, you can attempt right across the quiz, and you have to write your roll number. So please recall that when we sent you an email of the A1 Excel sheet was shared, the first column is your roll number, right? That will give me power to index different quizzes and aggregate all the marks at one place. So please do give write your roll number into that. So with this, let me close. Madhukar, are you there?
Sir, by what time we need to
Yes, sir.
submit the quiz
Yes, sir.
response?
So as of today, I have not given any last date, but I suppose that within 1 day or 2 days you give it. So at minimum 3 days it will be opened, because being a first quiz, later on we'll give less time, but 3 days. But once you open, it gives you 30 minutes per se, or kind of a per question. I think so. If I have 15 questions, I am giving you 30 minutes that way.
Okay. Okay.
There will some study material be provided because we have missed out some of the portion in the beginning.
So I have already shared. I have already shared a folder. So how many of you are not on WhatsApp group?
I am there on the WhatsApp group.
So just see.
Sir, I am not there on the WhatsApp group. Sir, I am not there on the WhatsApp group.
Okay, okay. Do you want to connect? Should I?
Yes.
Okay. On the screen, I'll just be showing kind of QR code. You just try to connect this. Let me share that QR code with all of you. Give me a moment, huh?
Where these PPTs are shared? Through WhatsApp,
PPT is, no, PPT is shared on a drive,
Okay.
which is there, which is the link is there onto the WhatsApp group. I'll also show you here. Just a moment. Give me a moment. Huh?
Okay, thank you, sir.
Can you see this QR code? You just try to read. Those who are not on WhatsApp can read this QR and join. And please confirm using your mic that you have joined.
Sir, I have joined.
The drive link also you have shared on the WhatsApp group.
I'll repeat for all of you guys because that will be visible once I repeat those. So I'll do that.
Sir, I have
Yes, sir,
joined.
that
Okay.
I have joined, sir. Now you
Great.
can share the drive, sir.
Is there any possibility new members can join and attend for this test and all this?
What's your question? Can you repeat?
New members who are not in that list, previous registered list can join. Some of our faculty colleagues are very much interested. Is it possible?
So, okay. So what I'll suggest that any new members, if they want to attend the classes, you can share the link. But will not be able to finally give them a certificate because that we have closed. Okay. So, but as far as if they want to use the material, if they want to attend the classes, you can share the link. No problem for us. Even they can join this WhatsApp group. There's no problem from our side. But as you know that this Microsoft team has got a capacity of about 350 members. Only 350 members can join with audio video, and we are already reaching that. And that's why we have not taken members. They will face any problem. But suppose you open this particular session on a bigger screen and more than one fellows are attending and all in your institute, so that's fine for us, right? That will be a better idea. That will be a better idea. If some students also want to attend, you can connect some screen in your institutions, and if they want to attend for a month and learn, that will be good. So that's a good idea that people are learning, so they can attend that way. And material you can share. You already have access. You can share the material, etc. So that is fine with us.
Thank you so much.
Thank you. So I think now everyone is on board. So on the WhatsApp group, I'll repeat everything for the new persons who have joined, and please confirm that all of you have received the email and you have your roll number. Anybody not knowing his or her roll number?
Yes, sir. I have requested Madhagar sir to let me know.
Yeah, so Madhukar ji will help on that. Madhukar, are you around? आप mic on कर लो,
Yes, sir.
Madhukar.
Yes, sir.
So
Yes, sir,
Madhukar,
yes, sir.
what Madhukar, let's do one thing that although WhatsApp may have latestly shared all those links, so you can just repeat those links again on the WhatsApp group number 1, and we can make a Word file where all these links are pasted and emailed to everyone, like the way we emailed the
Yes,
first
sir, that
email
will
of
be a great
inviting
idea.
them. So we'll use both the channels. So maybe from my side, I have Madhukar and also I have Shiv Kumar. Shiv Kumar, are you around?
Yes, sir, he is here.
तो शिव आप बाकी पार्टिसिपेंट्स को मेल कर दीजिए ये जो जितना ये आईडीज है, एंड इसके अलावा व्हाट्सएप पे भी इसको एक बार और रिपीट कर दीजिए. यू ऑल गाइज आर एडमिन ऑफ दैट. ओके, सो थैंक यू. एनी मोर थिंग?
But in WhatsApp, links are not seen, sir. Links are not there in WhatsApp.
Can you share the participant list also in the WhatsApp so that we will refer the serial number?
Okay.
Yeah,
Okay,
right.
I request Madhukar to share latest list of all the participants onto the group.
Thank you, sir.
So
Thank you.
in a maybe Excel or PDF wherein roll numbers are also given. That we will do, no problem.
Sir, I think.
Thank you, sir.
Any more queries? So okay, so let's.
Hello, good afternoon, sir.
Yeah. Yeah, please go ahead.
It's Dr. Anushka Kadge from Ichalkardi, sir. Hello.
Yes. We
Sir,
can hear
I
you. Go
wanted
ahead.
to know about the. Yes, sir. I wanted to know about the number of tests those will be conducted, whether it will be on everyday basis, and how much time will be provided to get these solutions of these tests. That means 2 days time, 3 days time are you providing?
Okay, so basically after every topic, it's not one session. A topic can be covered in one session, can be covered in 2 sessions. So after every topic, we'll release a quiz, a very, very easy quiz. If you refer to the PowerPoint, you'll be able to answer. Our idea is to engage you, to go through the papers. Even if you missed it, go through the lectures, recording or PPT, whatever suits you, and then you can attempt. So our idea is not to test you. Our idea is to engage everyone. Okay. And then the passing marks is also 60%. It's very easy to pass. And all these quizzes will combinedly will be used for final result and giving you a certificate of completion. And the time we are giving enough. So we are not putting any, as of now, I'm not putting any last date. But you should attempt within 1 or 2 or 3 days max so that you didn't forget to attempt and missed many. If you miss some number of quizzes, overall marks will reduce, right? So better idea to attempt. Only thing is that these are the timed quizzes. That means once you start, you have to finish within 30 days or 30 minutes or 40 minutes based on the quiz size.
Okay, sir, but resource links
Thank you,
please
sir.
share on the WhatsApp group.
It's already shared in the WhatsApp. We'll repeat that.
Yes.
So I think there is a raised hand from Dr. Manisha and Nirmalya ji. If you have any query, please go ahead. Abhishek, Mr. Abhishek has raised hand. Any more query? Okay. Okay, then thank you so much. Thank you for attending. Madhukar, if you want to say something,
Yes,
if you want to thank everyone.
Sir, I think only 3% have not got their roll number. First. And secondly, we would be intimating all the links and recordings link daily basis. And we also update you regarding the next session. And by evening of the day, all the recording will be available through the YouTube channel. So that's what I wanted to convey. And we are creating one more mail ID so that you can send whatever your queries there, because our official mail ID might be flooded with your mails. And secondly, and daily basis we would be intimating on the WhatsApp channel. So anyway, you can call me also. You have my telephone number, mobile number. So that's what. So thank you all of you. And it was a great meeting with you. Thank you. We'll close it. Yes.
Madhukarji, I have one request. See, what I'm saying is all the materials, whatever is going to be taught in next 3 weeks or so, all those material can be shared, and recording you can share at the end of the day.
First, we need to
All the material can be shared right now in the link in the WhatsApp group or the email, and the recording you can share at the end of the day. That will be helpful.
Yes. At the end of the day, by evening, recording will be shared.
Agreed.
Yes.
Agreed.
And the presentation
We'll
will
make
also, the link to the presentation will also be available to all.
Okay.
Yeah.
Yes.
Thank you.
So thank you,
So we
everyone.
close
We are closing the meeting. Thank you.
Yes. Thank you.
And they also have.
Thank you very much, sir.
Thank you.